Okay, functions and relations. So a relation is sets of ordered pairs. So if I have just a whole bunch of ordered pairs, whether that's represented in a table or on a graph, a relation is just a set of ordered pairs. A function is a type of relation where each input has exactly one output. So this means that all functions are relations, but not all relations are functions. So let's take a look at some different ways to represent relations. So you can represent it on a table, which just looks like an XY chart. You can represent it as a graph, which is using your XY axis and just plotting points, or you can use it doing a mapping, which lists the inputs that are connected to the outputs with arrows. So let me show you what those look like. So an example relation is 1, 5, the 0.23, the 0.32, and the 0.41. Okay, so for this one, we've got a table of values. So I put my X values, 1, 2, 3, and 4, underneath the X values. And then my Y values, which are 5, 3, 2, and 1, next to the corresponding X value. So the 5 goes next to the 1 because they're a point. The 3 goes next to the 2 because they're a point. The 2 goes next to the 3, and so on. All right? All right, if I'm representing it on a graph, I go to the point 1, 5, 1, 5, 2, 3, 3, 2, and 4, 1. Okay? Or you can do what's called a mapping. So I'm going to put all of my X values and I'm going to put all my Y values. Now I happen to put them in order, but really order doesn't matter on this like it does on the table, because I could make the arrow go in any direction that I want to. But because they're in order, the arrow does go straight across. When we're looking at these, you've already heard the words inputs and outputs. So your domain and range are where these words come from. Your domain are all of the X values. Another way to say that are all of the inputs. And another way to describe the domain is the independent variables. Now this is the exact same thing. All of these three phrases mean the exact same thing. It's describing the domain of the function or relation. So a range is the Y values, also known as the outputs, also known as the dependent variables. So these are all the exact same thing. So the Y values, outputs, and dependent variables. If you hear me say those three different words, they all mean the same thing, so I can exchange those words. So if we go back to that relation that we were using, 1, 5, 2, 3, 3, 2, and 4, 1. The domain is all of the, well, I can't really look at this and see it as X values, or excuse me, as inputs or independent variables, but I can look at it and see it as X values. The X is the first one. So my domain would be 1, 2, 3, and 4, all of the X values from the ordered pair. The range would be all of the Y values from the ordered pair. Okay? So sometimes the domain or range is a continuous set of numbers, meaning that there's no break between them. It's not a list of 1, 2, 3, and 4. It's everything between 1 and 4, or 1 and 7, or 1 and 12. And when you talk about everything between them, or it can be from negative 4 to 36, all the different possibilities of combinations of numbers. When it's continuous, that means that it includes all of the fractions, all of the decimals, it includes everything. And you normally are able to see that on a graph more than you're seeing it with a list of ordered pair. So if I take a look at this graph right here, my X values, my graph falls between the X values 1 and 7. Okay, so I'm not looking at when I'm thinking of domain, I'm not looking at the up or down. I'm just looking at where does my graph start and where does it end, reading it from left to right. So it starts at 1 and it stops at 7. So the way we write that is 1 is less than or equal to X is less than or equal to 7. The way I set it up is I write the 1 and the 7 and the X in between it, and then I just do my inequality signs. 1 is obviously less than 7, so that's how I knew to point them in that direction. Another way to write it is 1 and 7 with brackets on each end. This is called interval notation. So I'd look here and that said the or equal to, so I put brackets. If it didn't say or equal to, I'd put parentheses, and my graph would have an open dot. So the range is the smallest Y value to the highest Y value. So again, I'm not looking at how far left or right it goes. I'm looking at how low does it go and how high does it go. So the lowest point on this graph is 2, and it hits it twice, and that's not a big deal. So the lowest point is 2, and I can stop going up at 6. So the highest point is 6. So since the smallest value is 2 and the biggest value is 6, I write it as 2 and 6, put a Y in the middle, put my less than or equal to signs. I can rewrite that as bracket 2, comma 6, and then close the bracket on this end. All right, to decide if a relation is a function, Okay, you can check to see if the value appears more than once in the domain. It can appear as often as it wants to in the range, but each number can only appear one time in the domain or in the x values. So let's look at some examples. It'll ask you to give the domain and range and to tell whether or not it's a function. So if we take a look at this first chart right here. So your domain are going to be your x values and your range is going to be your y values. So 75, 68, and 105, 2, 2, and 3. Well, this one, again, the 2's, it doesn't matter that the range happens with numbers a couple times. That's not a big deal. What matters is if the domain has the same number repeated. So when you're looking at a chart, or at a table, you're looking right through here and seeing, are there any two numbers that are repeated? And it's not. So this is a function because each number in the domain or in the x values appears only one time. And that's okay. So that one is a function. Now the next one we're going to look at is the mapping. So I have got my domain. It's very clear. It's the group of numbers that are on the left side. So my domain is going to be 7, 9, 12, and 15. And my range are going to be the numbers on the right side, -7, -1, and 0. What happens with the mapping, though, is I can see that +7 is assigned to two different numbers. So whenever you have two arrows coming off a number in a mapping, that will tell you that this is a relation, but it is not a function. So this one is not a function because the 7 from the domain is mapped to two different numbers in the range. And last but not least, so you're given a graph. So this one we have to read to figure out what the domain is. And what I read from this is that I've got a high number and a low number. That's going to be my range. And then the farthest left to the farthest right is what's going to be my domain. So let's go back and start with domain. So how far left does this graph go? Well, it doesn't go any farther left than -3. So that's the low end of my domain. It doesn't go any farther right than +3. So that's the high end of my domain. All the x's that are in between the -3 and +3, that is my domain. So that's why I write the x in between those two. Then I'm going to go take a look at the range. The lowest this graph goes is -3. The highest this graph goes is +3. All the y's that are in between these are in my range. So this is all the y's that are greater than -3 and less than +3. So this one is not a function because there are values for x that have two y values. When I am sitting here at 0, it's got a +3 y value and a -3 y value. When given a graph, you can use what's called the vertical line test. All right, and this is a really quick visual way to determine whether or not your graph is a function. So a graph of relations can be tested to see if they're functions by using this test. So here's how it works. Given any graph, if you can draw any vertical line that touches more than one point on the relation, that is not a function. So let's compare these two. I have this relation drawn here, and I have this relation drawn here in blue. And then I've used the purple to do some vertical line tests. So for this one, no matter where I drew a vertical line, it only touched the graph in one spot. One spot there, one spot there, one spot there, one spot there. I can't draw a vertical line that touches the graph in two places. This one, on the other hand, I drew that. The very first vertical line that I drew goes through two spots. Now if I draw one over here, it doesn't go through any spots because the graph's not over there, and it would be silly to draw a vertical line over there to test. If I drew one right here at this point that's called the vertex, it would only touch in one spot. But just because it touches in one spot with one line doesn't make it a function. You've got to test other lines and see, is there anywhere that it would touch two lines? So for this one, any vertical line, and I've drawn just a couple examples, but there are infinitely many, it only touches the graph in one place, making it a function. And the vertical line, you only need one to touch in two spots, touches the graph in two different places, so this one's not a function.